All right, ladies and gentlemen, I'm going to start talking. Thank you for showing up for office hours. Once again, I am recording this session just like I did in the past couple of sessions, just because I want to document this and so that other people who are unable to view this may view it at a later point, okay? This question was posted for you guys at the end of office hours yesterday, and I hope everyone here got the chance to take a look at it, to read it, and to try to digest what it's asking for. We're going to take a look at how to solve this now. So this diagram here, this triangle, you've seen it come up a couple of times during your Khan Academy exercises. Do you guys remember seeing this? Michael, do you remember seeing this?
Yes.
Emma, you remember seeing this, right?
Yeah, so, sorry, I muted. I didn't realize.
No problem. So this diagram here, as I've mentioned before, this is a classic Regents question. You're bound to see it at least once, maybe in a multiple choice, or at the very least, even in a free response question in the Regents exam. I would even say that you will see a similar question come up in like the SAT 2 exams for college admissions, and even the ACT exams. So let's take a look at this, okay? Because it really does combine a lot of the things that you've been studying in Khan Academy, as well as concepts of similarity that we had talked about before we had to bunker down into remote learning. So let's observe for a moment. I have this triangle, and I'm going to ask everyone here to think about this, okay? This triangle here is being very, very, very general. But I'm going to ask everyone just to think about this with me for a moment. Let's say, hypothetically, right? If theta was, let's say, 30 degrees, okay? If this was 30 degrees, I'm going to use a different color, actually, instead of using black. Erase this. I'm going to use red instead. So let's say if this angle here was 30 degrees, what would this angle over here be? I'm not pointing at the 90-degree angle. I'm talking about this angle over here. What would that be? That would indeed be 60 degrees. I totally agree with that. Okay? So let's just think about this, right? If the overall angle, I'm talking about this overall, right? Kian, what is the measure of this overall? Kian, you're there?
Kian, you're muted.
All right. Would it be 60 degrees?
No, I'm talking about this overall angle. I'm talking about this entire angle here.
Oh, okay. That would be 90.
That would be 90. So, Kian, if that is 90, right, then what would be this little angle inside?
30.
That would indeed be 30. Right? And wait a minute. Kelvin, if this angle over here is 90, right, what would be the angle on this side here? What would be the angle there?
60.
So remember, a full line makes 180 degrees, right?
Yeah.
A full line makes 180 degrees. If the right-hand side here is 90, if this side here, this is 90, what would be the other side?
30.
90.
It would also be 90. This would also be 90. Right? Because it has to form a straight line. So it has to form a straight line. The other side must also be 90. And Diana, if this side over here is 90 degrees, right, what would the angle over here have to be, Diana? If you said something, you were kind of muffled.
Oh, 60 degrees.
60 degrees. Amazing. That's exactly it. So let's just take a look at this, right? We have a lot of angles everywhere, but one thing that is good, okay, even though there's a lot of things happening in this diagram here, one thing that is good, you notice that there are some angles that are repeating.
Yes.
Yeah, you guys notice this, right? You guys notice that there's a 30 here, which is a 30 over here, and there's a 60 over here, and there's a 60 over here. Do you see that?
Yeah.
Right? All right. So now imagine this with me, okay? If I were to alter this slightly, okay, I want to change this not to 30, okay, but instead change it to, I don't know, change it to like 50, right? What do you think will happen? What do you think will happen with this number over here?
It would also become 50.
It would also change to 50. And if you're having a difficult time accepting that, let's just think about this, right? If this angle over here is indeed 50, what would the angle over here become?
40.
It would have to be 40. Whoops. The angle over here would have to be 40. So then, you know, in order for this to be complementary, the angle to the left of 40 must also be 50. And what would the angle down here, which was 60, what would that now become, Emmett?
40.
It would also become 40. So all those things change, okay? And let's just do that exercise one more time to drive the point home, okay? To drive this idea home. If I change one more time, right? If I change this one more time, let's say this was 20, okay? Michael, what would this angle over here be? Michael, are you there?
What is the?
What is that angle over there on the left that I've circled?
It is a right angle now.
No. Going by the same logic, right? The two angles that I am now circling, right? Should they be the same or different again?
They should be the same. They're 20
They
degrees.
should be the same. That's exactly it. Those two should be 20, right? And then what about this angle over here that I am now, you know, signifying with a rectangle there? What should that one be?
That one must be a right angle now.
No,
70.
sorry. That should be 70. And Emmett, what would this one down
70.
here be? That should also be 70 degrees, right? So all those angles are the same. Why am I doing this? Because to demonstrate the following, right? So rather than being specific, it is much more powerful to be general, okay? So wait a minute. This problem started off with the following statement, okay? If this angle over here is theta, right? What should this angle over here be labeled as?
Theta.
It should also be labeled as theta, okay? So why am I doing this? Well, that's because there are three triangles here, okay? There are three overlapping triangles. There are two smaller ones sitting on top of a larger triangle. So what I'm going to do, okay, is I am going to have you guys take a minute, okay, and I want you to, and I want you to take a sheet of paper, and I want you to draw what I am drawing. Like I actually want you to do this, okay? So grab a sheet of paper, okay, every one of you. And I am labeling all three of these triangles with those angles there, like that, okay? Why am I doing
Isn't the third triangle, isn't that a combination of the two of those?
it is.
But all right. Oh yeah. I
Here,
guess.
I
Yeah, it's a little confusing. But
no. I'm gonna label theta up here to make it look a little more representative. So I want to label theta up here. Here, like that. So I want to give you guys another maybe minute or two, okay? And I want you to label as many of the sides as you can for these three triangles here using letters A, B, C, E, and E, okay? And again, I want to give you guys maybe 2-3 minutes to do that. Again, I want you to label all the different sides of this triangle with letters A, B, C, D, and E. Okay, let's just take maybe 2 minutes to do that, and I will time you guys. Just give me a second. I want to move this stuff over here. And this is what we're talking about right now. So take another 30 seconds. Again, I need you to label as many of those sides of those three triangles as you can with letters A, B, C, D, and E. I'm not asking you to do it randomly. It has to correspond with that original diagram that's given. Okay, so let's take a look at now that you've had some time to think about this, okay, for 2 minutes. I want to start with the big triangle, okay? Just because I don't know, maybe it'll be easier to see, maybe not. I don't know. We'll just have to. I'll just have to get a sense from you guys, okay? So I'm talking about this triangle over here, okay? This guy right here. So let's start with the hypotenuse of that right triangle. Okay, what is the how do we label the hypotenuse of that right triangle?
C
Emma,
plus
do you have an
D.
idea? Say that again.
C plus D.
I would totally agree. Diana, do you understand why it's C plus D? So if you guys are having difficulty viewing this or understanding this, okay, I'm going to highlight the triangles for you guys to see it, right? So this right here, what I'm highlighting in pink, okay, that is the hypotenuse. And this corresponds with that hypotenuse there. So Emmett is right, okay? This has to be C plus D. This is C plus D here. Now, we're going to try to figure out what this side is, okay, in green. Okay. Michael, you are so good at this for the past 2 office hours. That side length that's highlighted in green right now, is that opposite or is that adjacent to angle theta?
Opposite.
That indeed is opposite. Excellent. So if that is opposite, okay, my next question to you in the triangle over here on the left, okay, which side is opposite of theta? I'm talking about the giant triangle, right? Which side is opposite of theta? Is it A or is it B?
A.
It so is A. Good job.
Thank you.
Okay, so this side must be A. And Kian, what would, and again, this right here was side length A. What's the side length over here going to be then? The one I'm highlighting yellow.
As in like a number, or as in like just
A
what
letter. Is it going to be A, B, C, D, or E? Say that again.
Let's put it as B.
It will certainly be B, okay? And again, that side length there is adjacent to theta, so therefore that's what it corresponds to, okay? So that's going to be B. So this is going to be B here. I want to do the same thing, okay, with the middle triangle now. So I'm going to erase this. Okay, so again, I'm going to use the colors, okay? I want to know which side does that side length green, this green length that I have now, right? What does that correspond with? The triangle that I'm looking at is the middle one, right? So I'm talking about this triangle over here. This triangle. Okay. Diana, do you have an idea which side is opposite of theta in that triangle?
So that would be E.
It would be E. So I want to label this as E. So this side length, which I'm doing green, that's this length right there. Okay. And then the hypotenuse. Ricardo. Is Ricardo there? Or is he
Yeah.
reading? Okay, Ricardo. Which side is the hypotenuse in that blue triangle that I highlighted?
The blue triangle, side B is the hypotenuse.
Excellent. So I want to write this as B, okay? And then this side, again, that's hypotenuse, and that is indeed B. And then the last side, Kelvin, can you tell me what is that last side going to be? The side here that I am highlighting in pink. What is that going to be?
C.
That is indeed C. That is good. Okay, so this is C. And that's this guy right here. Okay. All right. So now that I have those two highlighted and figured out, okay, I want to do the same thing, okay, with the last triangle now. Now the last one here is a little trickier. What did I say, or what did we establish in the very beginning of this exercise? What did we say this angle was again? What was that angle?
Theta?
It was theta. It's going to be the same as this guy down over here, remember? All right. So if that's the case, okay, Emmett, why don't you do us the honors, okay? What is the horizontal length going to be? I'm talking about this
Right.
horizontal length here.
That would be D.
That would be D. Can you tell us the hypotenuse?
A.
And the side adjacent to theta?
E.
Excellent. Okay, now we have all three of these triangles labeled, and we're ready to go. Okay, the question was to figure out what sine theta, cosine theta, and tangent theta was. Okay, so according to this, okay, I need to know what sine theta is equal to. So for our answer, okay, will we have one answer, two answers, or three answers? Or is there an infinite number of answers?
3.
There's only going to be 3, okay, because I'm dealing with 3 different triangles here. We're going to have 3 different variations, okay? Now, let's figure out what that is. Let's say for the small triangle right now, okay? The small triangle, what is sine theta going to equal to? Kian, the other day, do you remember what was the ratio for sine again? Is it opposite over adjacent, adjacent over hypotenuse, or is it opposite over adjacent?
Opposite over hypotenuse.
Opposite over hypotenuse. Kian, can you do us the honors, okay, for figuring out what is sine theta for the small triangle in that case?
That would have to be. Wouldn't that be like D over A or something?
D over A. I totally agree. It would be D over A. Michael, can you do us the honors for figuring out what is sine theta in the middle triangle?
Sine theta in the middle triangle.
Right.
E over B.
It would be E over B. I totally agree. Good job there, Michael.
Thank you.
And then we're going to try to figure out what sine theta. Ricardo, can you do us the honors of figuring out what is sine theta for that last triangle there?
Sine equals sine of theta equal sine of theta. All right, so sine is opposite over hypotenuse, right?
Yes.
The sine of theta equals E over B.
It is. That's the one for the middle. But now we're on the last one. We're on the biggest triangle here.
So it equals C plus E over A.
The other way around. You got the right size, but it's the other way around. So it would be A over C plus D, right? Because A is the opposite side. All right. Emmett, my question to you right now. Are all three of these things equivalent, or are they all different?
They're similar.
Well, I want you to be more direct in your answer.
Well,
Are they all
are an
equivalent? Are they all
because
equivalent,
those
or are they
lines will
all?
not be the same.
Say that one more time.
Those lengths of lines that you'll get from those equations will not be the same,
True.
but they
Are the
share a common
proportions-
ratio.
Are the proportions equivalent?
Yes.
Yes, that is exactly it. So, therefore, our final statement, okay? Sine of theta will equal to D over A. Diana, what will D over A also equal to? Speak up.
E over B.
E over B. And lastly,
B plus D.
Wait,
A over
shouldn't
C
it be a squiggly line?
Nope. It is 100% equivalent, not similar. So when we say things are similar, okay, what is implied in that word again, Emmett?
That they share a common ratio?
That the sides share a common ratio. That's right. Okay. Do we say ratios are similar, or do we say ratios are equivalent?
Ratios are equivalent.
There you go. Okay. Because when we say, like, a ratio of 1 to 3, right, compared to, let's say, a ratio of 2 to 6, okay? Let's say a ratio of 1 to 3 and 2 to 6. Are these two ratios, do we say these two ratios, are they equivalent or are they similar?
They're equivalent.
They're equivalent. Okay, so that's why we use the equal symbol there and not a similar symbol. Okay. All right. So in that same train of thought, then, right, we're going to now figure out what's cosine of theta and what's tangent of theta. I want to give everyone here a minute to do that. Okay. Maybe perhaps some of you guys already figured it out. Okay, but I want to give everyone here a minute. Okay, to figure out what cosine of theta is equal to and what tangent of theta is equal to. So go ahead. I want to give everyone 1 minute. Okay, go ahead. All right, so let's take a look at this together. Kelvin, can you tell us what is cosine? What is the ratio for cosine? What was that? What were the notes that was given the other day? What was cosine again?
Hold on.
No problem.
Puerto Rican.
Jason over hypotenuse.
That's right. This was adjacent over hypotenuse. And Kelvin, while you're at it, what was tangent of theta again equal to?
I gotta get my
Opposite over adjacent.
Opposite over adjacent. And one last thing, okay? And even though we did this for sine already, what was that for sine one more time, Kelvin?
Opposite over hypotenuse.
Excellent. It was opposite over hypotenuse. So we have, just to drive this home, okay, that these ratios are equivalent because of the very fact of how we are defining what, these things are. Okay, so adjacent over hypotenuse. Let's try to get this, let's try to figure this out, okay? Diana, can you tell us what is the cosine theta equivalent to for the small triangle? Diana, you're there?
It's E over A.
Say that again, I'm sorry?
It's E over A.
It is so E over A. Kian, can you tell us what is cosine theta for the middle triangle?
Cosine theta? That would have to be, sorry, you were asking for the cosine theta. So,
Yes.
Would that be, okay, would that be C over B?
That would so be C over B. Emmett, what would it be for the big triangle?
It would be B over C plus D.
Thank you for that. And then for tangent, we're again going to figure out opposite over adjacent, okay? For tangent of theta. Now let's do it again for the small triangle. Michael, can you do that? Can you tell us what it is for the small triangle?
What is tangent for the small triangle?
Right, tangent of theta for the small triangle.
Tangent is opposite over adjacent, right?
That's right.
For which triangle? The
Small triangle.
the smallest one. Okay. D over E.
D over E. That's right. What would it be for the middle triangle? Ricardo, what would it be for the middle triangle?
Oh yeah, I have it on word view. In the middle triangle, the sine or
tangent.
Then the middle triangle would the tangent of the middle triangle.
Yep.
That's opposite. That's opposite over
Adjacent.
Right?
Yep.
So it would be E over C.
Amazing. And the last one. Emmett, can you tell us what it is for the last one?
The last one is A over B.
A over B. That's it. Okay, so that right there, okay, is the answer for that enrichment problem that I posted yesterday. So this is the final answer right here. Whoops. Too much. Okay. You guys have any questions?
No.
No?
Really, no.
Okay. So I'm gonna post I guess this is going to be like the new pattern. I'm gonna post like the Khan Academy material for you guys to work on in the beginning of the week. And we'll go over things during office hours. I'll assign like various videos for you guys to watch, but I also want to see the notes that you guys are taking for them. And then once you guys are done with those like mandatory assignments, then we'll talk about these enrichment exercises. Okay?
Mr. Chan, did we finish all the work for this week?
We did finish all the work for this week. Yeah,
It was just that one page?
it was just that one page from Khan Academy. That's it.
Cool.
Okay. So I'm gonna stop recording. Let's see here.